So yes, we'll just jump straight to the counting principle. Right. So please go ahead, Elsie, and read the statement for us. Just the statement.
A four-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated.
In fact, please read the entire thing, Elsie.
Question 10.2.1. How many possible four-digit combinations are there to open the lock? And then 10.2.2, calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2.
Yes, Elsie, thank you so much for that. Oh, well, here is a four-digit code, like the one that you use on your cell phone if you're using a PIN, for instance. Well, I'm using a fingerprint. Nonetheless, a four-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. All right? Digits may not be repeated. Oh, that's fine. So this means we are trying to perform four tasks in this case. So 1, 2, 3, and 4. Good. But now they say to us the code must be even numbered. For instance, if I decide to say the PIN that opens my phone, if I choose to say it's 2001, for instance, this is an even numbered PIN. Is it? No, it's not. It's an odd number because the last digit is odd. Okay. What about if I say my PIN is 87, maybe let's say 91, or even a 3 here. Or maybe let's make it interesting and say 5. Is this an even number? And the answer is no, it's not. But what if I choose to say my PIN is going to be, maybe let's say 7, 9, and let's say 8, 2. Is it even now? And the answer is yes. Why is it even? That's the most important question to answer. The reason why the PIN is even, it's based solemnly on the last digit. If the last digit is even, then the PIN will be even. The entire thing will be even. But if the last one is odd, it doesn't matter whether the first one was even. It will be odd because the last digit is odd. Yeah, I hope you've got it. So then let's go on and talk about this. Then they say the code must be an even number and it may not contain the digits 0 or 1, which means that we are only allowed to use 8 digits in order to form this combination lock. Well, that's fine. Then they say no repetition is allowed. Well, that's very, very good. So let's go. The question here is asking us how many possible four-digit combinations are there to open the lock? And even though they didn't say how many possible four-digit even combinations are there, even though the word even is not there in their statement, but you know that it must be an even four-digit code. Because the statement told you that it must be even. Anything that is said in the statement is applicable to everyone in the questions. So let's go. We now know that 0 or 1 cannot be used, so we have 8 numbers to choose from. It's actually 2, 3, 4, 5, 6, 7, 8, and 9. Good. Then we said in order for this to be even, it depends on the last digit. So now we need to go and choose even numbers. We know that 2, 4, 6, and 8 are even numbers. So this means I can choose one even number from a total of 4 even numbers. That's what it means. Okay, fine. Now one number has been chosen. It means I'm left with 7 numbers that I can use. So I can now put a number on the first position from 7 numbers, from 6, and from 5 on the third position. And this will actually be 7 by 6 by 5, and then we say by 4. Yes, that's what we are saying. It's very much different to when you say you have 8, 7, 6, and 5. Because when you say this, it won't really be an even number. It's like they're saying, how many 4-digit numbers can you form? Not necessarily that it's even or not. So it's two different situations. And of course, when I now press this into my calculator, which was given to me back in 2019, I find that we have 840 possible 4-digit combinations. Yes, just to clarify once more for those who are home and enjoying this recording, in order for a code to be an even numbered code, it's not necessarily supposed to be composed of even numbers only. Like it doesn't have to be 8, 4, 2, 6 in order for it to be an even number. No. Which means we don't necessarily have to use even numbers only. That's what I'm trying to say. Even this one is still an even numbered code. 3, 4, maybe let's say 9, 8. It depends on the last digit in order for it to be even. Okay. Now we can move on. The next question says, please calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. Well, forget about opening it on the first attempt, but let's just say, what is the probability that you will open the lock if it is given that the code is greater than 5,000 and the third digit is 2? Okay. We have 2 restrictions now. The entire code must be greater than 5,000. And the second restriction is the third digit must be a 2. So the question is, what must happen in order for a code to be greater than 5,000? That's a very good question. Well, before I tell you, is there anyone who has an idea? What must happen in order for the code to be greater than 5,000?
It must be 5,000 and like the next digit, it mustn't be a 0. It must be like 1 or 5 or something like that.
What about the first digit?
It shouldn't be 0. It must be like 1 or 3 or, any number
So
other
let,
than 0.
Let's say I have 1389. Is this code greater than 5,000?
No, sir, I mean like it must like be between it must be 5,000. No, it must be 5,001 and above.
Okay, this is an important question I'm asking you here, Elsie. What must the first digit be in order for the code to be greater than 5,000?
It can still be five or six or seven or eight or nine.
Can it be 4?
No.
Right, you've cracked the code. Yes, Elsie. I see it was Benny Nyunja per se. Sorry, Simon. But she just killed it. So we'll give you another one. So don't cry, Simon. Yes, you're right, Elsie. In order for the code to be greater than 5,000, that's if and only if the first digit is 5 or greater than 5. You are right. Even if the first one is 5 and others are zeros and this one is a 1, well, this code is greater than 5,000. Okay, thank you so much for that. So what does it mean? It means that the number that I'm going to put on the first position, I can choose between 5, 6, 7, 8, and 9. That's what it means. But remember, it must be an even digit after all. Don't lose sight of that. So for this one, it can happen in many ways. In 3 ways to be exact, and you need to consider all the possibilities in your probability. Please keep that one in mind. What am I saying? And that's a good question. This is the first way in which this can happen. Now, it's the first possibility. Listen to this. We know that the third digit must be a 2. So this means on the third position, we have one number that must be seated there. We are definitely sure that one number is seated there. So this means out of 8 numbers, we now have 7 numbers that we can choose. Now we come for the first position. What is it we say on the first position? We say the number that we need to use. Okay, we don't really go to the first position first. Sorry for that. Sorry. Because we don't need to, we mustn't lose sight of the fact that the code must be an even number at the end of the day. So it means after putting a 2 here, we still need to come back and go to the first position. No, the last position, I mean. But remember, this is what I said to you. I said, for this one, it won't happen in only one way. It can actually happen in a number of different ways. So what's the first way in which it can happen? I want you to see. From our even numbers, we know that 2 can't be used anymore. So this means we now need to choose one even number from 3 even numbers. But the first possibility is going to be when 4 is the number that we put on the last position. So in other words, when we choose to say, well, definitely 4 is the last one, then that's the first possibility we can get. The second possibility we can get is when we say 6 is definitely on the last position. And the third possibility we can get here is when we say 8 is on the last position. But of course, on the third one, we still have a a 2 there. Those are the three cases you need to consider. So then let's go. Now we say on the first possibility, I know that I now have 6 numbers to choose from, but am I really going to choose from 6 numbers now that 2 of them have been used up? Am I really going to choose from 6? And the answer is no, because we know that the code must be greater than 5,000, which means that I can choose a 5, a 6, a 7, or a 8, or a 9, which means I actually have 5 numbers from which I can choose in order to place the first one on the first position. So then, 3 numbers have been used up out of 8 numbers. So, how many numbers can I choose in order to put a number here? Well, I can now choose 1 number from 5 numbers. And the reason why I'm saying from 5, well, this is because the 2 and a 3 are now available to be placed on the first position. Let's repeat. The first possibility is when we are definitely sure that 4 is on the last position. And if that's the case, and we also know that 2 is on the third position, then it means we have 6 numbers from which we can choose in order to put a number on the first position. But out of those 6 numbers, we need to make sure that the code is greater than 5,000. That means I can either use 5, 6, 7, 8, or 9, which is a total of 5 numbers. Now I have placed 1 number on the first position, which means that 3 numbers have been used up. And since I know there is no restriction on the third one, then this means that I can now use these ones as well. So 5 numbers I can choose from. That's the first possibility. Then we go to the second possibility, which is when we are definitely sure that 6 is on the last position. Yes, this is the second possibility. So when 6 is on the last position, we still have 6 numbers from which we can choose. But in order to make sure that the code is an even number that is greater than 5,000, that's what I should have said, greater than 5,000, this means I can now use 5, 7, 8, and 9, either one of those 4. I have 4 numbers to choose from now. But of course, there is no restriction on this one, so I can still choose from 5. And the last possibility is when 8 is on the last position. So when 8 is on the last position, what is going to happen? Well, once again, I still have 6 numbers to choose from, but those that are eligible in order for this code to be greater than 4,000 are actually 4 once again. And of course, I can now use the 5 other numbers. Yes, that's what I'm saying. So then this means the total number of possibilities I can get here will be 5 by 5 by 1 by 1 plus 4 by 5 by 1 by 1 And then you say plus 4 by 5 by 1 by 1. That's what we are saying. 5 by 5, 4 by 5, 4 by 5. And we find that the number of possibilities will be 65. But the question is asking for the probability, so you can now go on and say the probability will be the number of outcomes in this event divided by the total number of all the possible outcomes, which is the sample space. And we find that our probability here will be 13 over 168. There is not one way in which this can happen. It was 3 different ways, and you needed to consider all 3 of them. Doing it once and multiplying by 3 was not going to cut it, because as you can see, it's 4 by 5, 4 by 5, but this one, it is 5 by 5. Considering possibilities was really the best way out, you asked. So the question that was asked now was, why did we not just say, well, since 2 has been used on the third position, why didn't we say we now have 3 even numbers to put on the last position? Why did we not say that? Why did I consider each possibility separately? And the answer here is we needed to be specific. Because if we just say we can choose 1 even number from 3 even numbers, the question begins, it's which even number did we put on the last position? We don't know because the answer is vague. It could have been a 4, a 6, or an 8. We don't know which one. So we need to be specific so that we know that if I put a 4 on the last position there, then out of a total of numbers here, these are the available ones from which I can choose and put on the first position so that the code is greater than 5,000. Yes, we had to know that if I took away a 4 and put it on the last position, then out of these 8 numbers, I'm now left with 5, 6, 7, 8, and 9. 5 numbers that I can put here. We had to be specific, that's what I'm trying to say. If I put a 6 here on the last position, as I did, of course, I need to see that the remaining numbers are 5, 7, 8, and 9. 4 numbers that are eligible, that qualify to be placed on the first position so that the code is greater than 5,000. Yes.